Okay, welcome to 14.2 Parallel Lines Cut by a Transversal. We'll learn what a transversal is for one thing today. All right, so start by filling in all the missing angles here. Now, let's just look at the top. If you look at the top, that should look like the last lesson, right? So the top B is a vertical angle to the 65. Vertical angles are congruent, the same. A is a linear pair along a straight line there. Linear pairs or supplementary angles add up to 180. So we'll subtract 65 from 180 and we get 115. So A is 115 and C must also be 115 because it's a linear pair with the 65 and it's vertical to A. Down here, same thing, right? There's the 65. H is vertical to that 65, and E is a linear pair with that 65, and G is vertical to E. So notice we have the same numbers top and bottom here, right? This area up here should look identical to that area except for the letters being different. Now, what's going on here is that these lines are parallel. For this to have happened, those lines have to be parallel. And that's how you show that two lines are parallel, at least one way, that these little arrows there. And when two parallel lines are crossed by a third line, we get this pattern that you see. And this third line that's crossing the other two lines is called a transversal. It crosses or cuts the two other lines. And that's why today's lesson is called Parallel Lines Cut by a Transversal, Crossed by a Transversal. So what is the transversal in this picture? Well, the transversal has to be this line EF, you could have called it line FE, because that's the only line crossing two or more other lines. Right now, I drew these like these other two were parallel. They don't have to be parallel. The transversal just has to cross two other lines. Right, line AB, for example, only crosses one line. Then it's not a transversal. You have to cross two or more. We're not going to do more, but if two or more other lines. So what's the transversal in this picture? Well, it has to be EF again. I've just sort of moved things around ever so slightly, but EF is the transversal. It's crossing the two other lines. When parallel lines, that's how you know these are parallel because of that symbol there, are crossed by a transversal, you get corresponding angles that are congruent. Now this word corresponding in math always means matching. I wish we would just use matching and then everyone would know what we're talking about. But corresponding angles are congruent. The matching angles are congruent. So let's find out what the corresponding angles are in this picture. This is a transversal crossing two parallel lines. Well, A matches E, right? A and E are in the same location relatively in the picture. So find the other corresponding matches. Well, B is in the corresponding location with F. D is in the corresponding location with H. I skipped C there. And C is in the corresponding location as G. And what's going to happen is A and E are going to be congruent. They're in the same location in the pictures. If you look back at the warm-up, A and E, right, they look like they're the same size in this picture. And the fact they always are if these two lines are in fact parallel. And B and F will be congruent to each other. Right? They look the same size as each other, and they are. They have to be if the lines are parallel. So, given what I just told you, fill in all the missing measurements. Well, let's start with the easy one. C is vertical to A. So vertical angles are always congruent. A and B are a linear pair, so they must add up to 180. So B has to be 130. And D has to be 130 because it's a linear pair with A or it's vertical to B, either way you want to think about it. Now we have this whole group down at the bottom. Since these little lines are parallel to each other, that means E is congruent to A. And so E is congruent to A, so it's also 50. And H is congruent to D, so it's also 130. Now it also has to be 130 because E and H are a linear pair, right? They're along a straight line and they're adjacent to each other. B and F have to be the same measurement as each other, and C and G have to be the same measurement as each other. And as long as you have a transversal crossing two parallel lines, you get this pattern. So fill in these. Well, A's got to be 105. It's vertical to the Y. X must be what? 75. I almost wrote 85. 75 degrees because it has to add up to 180. Z has to be 75. And you have to get the exact same pattern up here. Now, if these are not parallel, for instance, I told you they weren't parallel or those symbols were missing, this pattern would not happen. It can only happen if those lines are parallel. All right, this is the same picture, just making it look a little different. So we're just going to find, and please read these because you don't want to do extra work. This says find the measure of angle A, so you don't have to find them all. Well, let's think about this. This one's 114, so its corresponding angle over here is B, right? These are parallel lines being crossed by a transversal. So this B is also 114 degrees. So A is a linear pair, or supplementary, you could even say, with B. And so they must add up to 180. And so A must be 66 degrees. And in fact, every angle in that picture is either 66 degrees or 114 degrees. Find the measure of D in the same picture. Well, several ways we could do that. The easiest way is realizing that D is vertical to B and therefore must be the same measurement. Or it is a linear pair with A and it must add up to 180. Either way, it has to be 114 degrees. Everything in that picture is one of those two measurements. Find all the angles with the same measure as A. All right. So we don't know what the measurement is, but we know Y. So we're going to give the reason as well. Y is the same because Y. So write the reason there because it's vertical to A. Find another one and give a reason. Well, W is the same as A because it's corresponding is the word. It's in the matching location to A. There's one more. It's U. Now there are two different reasons U has to be the same measure as A. Well, let's see. One of them, we could say U is vertical to W, right? And we already said W corresponds to A. Or we could say U is corresponding to Y, right? It's in the same location as Y. And we've already determined Y is congruent because it's vertical to A. Find all the angles with the same measure as angle V, right? So angle V is right there. And now give a reason each time. Well, T, because it's vertical to V, and vertical angles are always congruent. And Z, because it's corresponding to V. And then X, because X is either corresponding to T or is vertical to z, either one is the reason it has to be congruent. Find the measure of x. Okay, so we sort of did this the other day. So if that's 3x, this angle, and these are parallel, this also has to be 3x. Well, now we've made a linear pair, adjacent angles along a straight line. If we've made a linear pair, they have to add up to 180. So we've got a very simple equation, 9x equals 180. X there has to be 20 degrees. All right, try another one. So you could put the 6x plus 10 down there or the 4x up there. But either way, you're making a linear pair. And linear pairs always add up to 180. Now be careful on this one. Well, this 5x goes there. Are these a linear pair? No. So what's the correct equation? No, they're back to back. They're vertical, so they're equal, right? So you get an even simpler equation. But this is the one people will mess up on the test and say they add up to 180. No, they are not a linear pair. They're back to back. They're vertical. I think 5 it goes into 155 31 times. All right, we're already at practice today. After that long one yesterday, I think that's good. So same as C. Well, A, and give a reason because it's vertical. G, and I should say vertical to C, corresponding to C. And you can give one of two reasons for E. E because it's vertical to G, or you could write the other one, which is corresponding to G. No, vertical to G or corresponding to A, sorry. Find the measure of angle B. Well, this one's 141, this one's 141. So B is not 141. It is supplementary or linear pair to that. It is 39 degrees. Notice I didn't say parallel lines. They don't have to be parallel. They just were in this lesson.